Okay, hello, boys and girls. We're going to be on page 6 of the probability packet, and we're going to take a look today. We're going to start with something that looks kind of familiar, and that's this chart here that helps us think about the likeliness of an event happening. And so there were different words last time that we looked at that might help us describe the type of event and how likely it is to happen. So impossible, less likely, equally likely, more likely, and certain. Those are all words that help describe the likeliness that an event will take place. So with these words, we're going to think about the fractions, percents, and decimals that we can use to help us show that particular type of event. So if something's impossible, as a fraction, we might say like 0 out of 100, or 0 out of anything, 0 out of 2, 0 out of 3. That 0 as the numerator is important. As a percent, if something is impossible, it has a 0% chance of happening. Cannot happen, 0%. And then as a decimal, that decimal is also 0. Okay? So if something's impossible, it's not going to happen. You would use that number 0 to represent its possibility. If something is certain, it's kind of the opposite of impossible. So we're going to go to certain next. If it's certain, it is 100% likely. Like it's going to happen. The fraction for that, if it's out of 100, would be 100 out of 100. If the numerator was 3, or if the denominator was 3, certain would be 3 out of 3. So just depending on the fraction, depending on the denominator, will depend on the numerator. The likelihood as a decimal, well, as a decimal, if 0 is impossible, certain is 1. Because we would move the decimal point over 2 times to the left in the percent to get the decimal, and in this case it would be 1. Next, we're going to look at equally likely, which is a fraction. If we're thinking of out of 100, it would be like 50 out of 100. Or if you simplify that, it would be 1 out of 2, 1/2. Now, as a percent, if something happens half the time, that'd be 50%. And as a decimal, that would be 50 hundredths or 5/10. So you might see it written as 5/10 or 50 hundredths. They're all right both, I suppose. All right, so the other two are they're kind of more of a range. It's not an exact number. So if we're looking at less likely, I'm going to start with percent here. It might be easier to understand this. So if it's a percent, it'd be between 1% and 49%. And again, I'm looking at just whole number percentages. Like you can have decimals in there that might be more than 49 and less than 50. But it's somewhere in that range of 1% to 49%. It could happen. It's just less likely to happen. As a fraction, we might say that's somewhere between like 1/100th. 1% is 1 out of 100. Somewhere between that and 49 out of 100. Okay. As a decimal, 1/100th is 1%. It's 1 out of 100. 49%, 49 out of 100. So it'd be 49 hundredths. So somewhere in that range would be less likely. The last one would be more likely, and that's somewhere between 51% to 99%. So it's not certain to happen, but it's more likely of a chance that it may happen. As a fraction, that would be 51, somewhere between 51 hundredths and 99 hundredths. Now again, these fractions don't have to be out of 100, but it can be helpful to think about these fractions when they're out of 100. And then as a decimal, somewhere between 51 hundredths and 99 hundredths. All right, so let's take a look at some examples. So I have 5 examples here. I'm going to show you one at a time, and we'll see where we put these. So here's the first example. I get more than 4 hours of sleep tonight. Now, that's not impossible. It's also not 100% certain. So typically people get more than 4 hours, but sometimes you never know. So I'm going to put that under more likely. It's more likely to happen than not. Not certain, but more likely to happen. I roll a 2 on a die, so it's like a dice. So it's not impossible. You can get a 2 on a die. It's also not equally likely because there are 5 other numbers, so it's actually less likely that's going to happen. It's more likely that the other 5 numbers are going to happen. So we'll put that under less likely. I roll a 2 on a die. Here's another example. Our next season is summer. Well, we're currently in spring, so I am certain that our next season is summer. That's 100%. I'm 100% sure about that, so I'm going to put that. All right, next example. A baby will be president. Well, like a baby as they currently are. Not like a baby will one day grow up to be president, but will a baby younger than 1 year old be president? I'm going to go with impossible on that because of the way that the laws are written. It'd be a hard election for a baby to win, too. All right. I flip a coin and get tails. Since heads and tails have an equal chance of being arrived at, I'm going to put that under equally likely. That's an example of one of those events. You flip a coin, you get tails. Okay. So next we're going to take a look at more specific examples, and we're going to use some of these words and also use some of these types of numbers to describe specific events. Let's take a look at the same page. So we're not flipping a page, we're on the same page. Okay. You flip a coin on heads. Now, the chances of that happening are 50-50. Either it's going to land on heads or tails. So this was, what type of event is this? This is equally likely to happen. Equally likely. So as a percent or fraction, we would say that because it's equally likely to happen, there's only 2 chances. Oh boy. There's only 2 outcomes, I should say. It's going to be 50%. June will have 30 days. Well, June has 30 days. So the probability that June will have 30 days is certain. I'm 100% certain that this June will have 30 days. So as a percent, I'm writing that as 100%. You will roll a 3 on a die. Now, how many sides are there on a die? There are 6. So to roll a 3, I'm not certain. I'm also a less certain than like equally likely. So this is probably a less likely event. Okay, less likely. Now, it's harder to write that one as a fraction because it's 1 out of 6. And you would write that just as 1 out of 6. To write that as a percent, that would have a repeating decimal. So I'm just going to leave it as 1 out of 6. The Bills will win the World Series. Well, I love the Bills. They're awesome. But I don't think that they will ever switch to baseball and then win the World Series. At this point, this type of event would be impossible, which would be a 0% chance of the Bills winning the World Series. Okay. A spinner is split evenly into 3 sections. I'm going to draw this. So you got a spinner here. Oh, brother. Okay, and it's split evenly into 3 sections like that. It has 2 sections in red, 1 in blue. So pretend that those are all equal. So you got 2 sections in red, 1 in blue. Well, that's supposed to be blue. That was also red. If that was the case, I'd be certain that it would be on red. Here we go. There's the blue one. The spinner lands on red. Well, if you look here, it's more likely to land on red than blue. So it's not certain to land on red. So I'm going to say more likely because there are 2 chances for the spinner to land on red and only 1 chance for it to land on blue. So as a fraction, because there's 3 possible outcomes, 2 of them would be red. I would say that probability is 2/3. Okay. 3 colored tiles are in a bag. 1 red, 1 blue, 1 green. Green is selected. So you have 3 tiles, a red, I'm going to kind of draw this out too, red, blue, oh boy, and green. Okay, so you have 3 tiles, red, blue, green. What is the probability that green is selected? Well, you're more likely to pick either a red or a blue because there's only 1 green out of 3. So we'll say that this event is less likely to happen. Less likely. And what would be the fraction for that? There's only 1 green out of 3 possible greens. Okay. All right. Now, what I have prepared are 4 different events here that are going to fit into one of these categories. Certain, 0%, equally likely, or 3/4. So I'm going to reveal it, and then we'll see where each one goes. You roll a 6-sided die and get a 9. Well, 6-sided die, 1, 2, 3, 4, 5, 6. What is the chances you're going to get a 9? That's likely to be impossible. Okay, so I'm going to put that here next to 0% because that's what 0% means. It means impossible. Perfect. All right, let's take a look at another example here. You have a 4 equal parts spinner with 3 parts blue, and you land on blue. So I'm going to draw that out. You got 4 equal parts spinner. So split into 4 parts. This one's blue, this one's blue, this one's blue. What are the chances are that you'll land? Let's say this one's red. What are the chances are that you'll land on blue? Well, there's 4 possible outcomes. 3 of them are blue. So this particular event would go in the last column here, where 3 out of 4 would be blue. So this would be more likely. It's more likely you'd land on blue because you have 3 blue and only 1 red. All right, we got 2 more. This one's either certain or equally likely. Let's see what it could be. You flip a penny and get heads or tails. Well, you either get one or the other. That's certain to happen. You're either going to get heads or tails. It's not likely that it's going to land on like the edge. So because that is certain, the percent for that, we're 100% certain that that's going to happen. So we're going to put 100. 100%. All right, last event here. Last event. What's this going to look like? You roll a die and get an odd number. Okay. Well, when you roll a die, you get 1. You can get 1 or 2 or 3 or 4 or 5 or 6. Well, which ones are odd? 1 is odd. 3 is odd. 5 is odd. So that's 3 out of 6. So half of them are odd, half of them are not odd. You're equally likely to get any one of those numbers. So equally likely. The fraction we could write for that is there are 6 possible outcomes out of 3. And that's the same thing as 3/6 is the same thing as 1/2. So there's 3 odds, 6 total numbers. That's the same thing as a half, 50%, or equally likely. All right, the last thing we're going to do is take a look at the alphabet. Because the alphabet has 26 numbers, and we're going to take a look at different events that could take place when pulling a random letter from the alphabet. So we're going to go to the next page, page 7. It says each letter in the alphabet is written on a slip of paper and placed in a box. You draw a letter from the box, means pulling it out. Write a ratio and use one of the terms below to describe the event. All right, you draw a vowel. Well, how many vowels are there? A, E, I, O, and U. So the ratio would be 5. There's 5 possible favorable outcomes. And then how many total letters are there? How many total outcomes could there be? There'd be 26. So if that's the case, there's only 5 in there out of 26. It's not impossible. It's not equally likely. It's more unlikely. or less likely. We've been using the word less likely, okay, or the phrase less likely. All right, you draw a consonant. Well, if it's not a vowel, it's a consonant. So if there are 5 vowels, how many are consonants? Well, all the other letters would be consonants. So there are 21 letters that are consonants out of a total of 26 letters. So if you're going to draw in and pick out a consonant, you are more likely to get that because more than half of the numbers are consonants. It's more likely. You draw a W. Well, if each letter is put in there, there's only one W out of a total of 26. 1 out of 26. Not impossible. Certainly not impossible. It's just less likely. The percent chance of that happening is very low. It's probably around 3 or 4% that you'd pick any individual letter by chance. Probably more toward 4%. You draw one of the first 13 letters of the alphabet. So how many letters are in the first 13 letters? That'd be 13. A, B, C, D, E, F, G, H, I, J, K, L, M. So there are 13 favorable outcomes there. And how many letters are there? Well, there's 26. Do you notice anything about this fraction? Excuse me. This is the same thing as 1/2, because if you divide the top and bottom by 13, that's the same thing as 1/2. So because the ratio is equivalent to 1/2, we would say that this is equally likely because there are the same number of letters in the first 13 as there are in the last 13. So this is equally likely to happen, that you'd pull out one of the first 13 letters of the alphabet. You draw a vowel or, this key word here, or, vowel or a consonant. Well, that's all of the letters. Every single letter is either a vowel or a consonant. So that would be all of them. So 26 out of 26, which is the same thing as 1, right? So this is certain. If you put all the letters in a bag and you pull one of them, you're definitely going to get a vowel or a consonant. So that's 100% certain. You draw one of the last 10 letters. The last 10. Well, how many letters are in the last 10? There's 10 of them. How many total letters are there? There's 26. So that 13 out of 26 is half. That's equally likely. This is less than that. This is only 10 out of 26, so it's less than half. So we might say less likely for this. It's still certainly possible, but it's less likely it's going to happen. You're more likely to pull out the first 16 letters if that's the case. All right. You draw or pull out the 28th letter of the alphabet. Well, in the alphabet we use, there are only 26 letters, so it would be impossible to pull out the 28th letter, because out of the 26 letters, 0 of them are the 28th letter of the alphabet. So 0 out of 26, and we'd say that is impossible. That's impossible. 0, this is 0% or 0. You draw one of the letters in your name. So it depends on your name. Now, for me, my name, I'm going to go with full name. I was just going to go with last name, but I'm going to do my full name. You could do your own full name if you want to. So Michael. You could do my name if you want, or you could do your own name. So I'm going to see how many letters I have in my name, and we'll see the probability that I'm going to pick one out. So M is 1. There's 2 I's, so I'm only going to count that once. There's a C. I have an H in there. I have an A. I have an A. L is in there as well. I have an O and a V and an N and a G. I should have done tallies. Missed opportunity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I was hoping for, equally likely, but I have 11 letters in my name. If I included my middle name, it probably might still be, no, I'd have 12. But even if I included my middle name, I'd still only have 12. This is less than half, so this would be less likely for me to pull out a letter from my name. So it's not, again, not impossible. It's closer to equally likely, but a little less likely. You draw a letter in the word Mississippi. Okay, well, let's see how many letters we have. M is a letter in Mississippi. I is in there 1, 2, 3, 4 times, but we only count that as one letter. S is in there 4 times. So we only count that as one letter. And P is in there twice. We only count that as one letter. So there's only 4 different letters in Mississippi. So the chances of that are 4 out of 26. So that's another case where that's a lot less than half. We'll call this also less likely. All right, last one. You do not draw the letter K. So you draw anything but the letter K. Well, how many letters are in the bag? Or I guess it's a box. How many letters are in the box that are not K? Well, all of them except one. So there are 25 letters that are not K out of 26. So it's you're pretty sure you're going to pick out one of those letters that are not K. So this would be more likely. Not certain, because again, you could still pull out that K, but it's more likely that's going to happen than not. All right. So it's fun to think about the letters sometimes because there's a lot we can do with them in terms of probability. I hope you're doing well. I hope you're having a great day, and I hope to see you soon. If you have any questions, let me know. And other than that, I'll see you later. Bye-bye.